Now we'll talk Dr. Mark Allen. Please.
Okay, hello everybody. My name's Mark Allen. Introduced myself briefly before, but it's worth perhaps to say that I'm an astronomer. I do research astronomy, and for the last 10, 12 years or so, I've become involved in the use of data services in astronomy, the CDS, and the development of the virtual observatory. I think one of the main messages I want to give in this talk is in the title, the CDS experience, contributing to the interoperable VO framework for astronomy. So I want to show you that the CDS does its job. It's a data center. It provides services to the global astronomical community, and we like to think, well, we really try and do that as best we can. But an important component about that is contributing to the overall infrastructure that all of the data centers can build on in astronomy to make things work together, because by contributing at that level, we sort of help with everybody else raise the whole level of interoperability in astronomy. And I think it's also important to realize the size of astronomy is not big enough to have an independent, separate standards body which we then comply to, but rather the data centers that really do produce the data and make the services available are the ones that are at the basis of developing the standards along the lines of what Pepe's just mentioned. So the CDS, it's in France. It's a French acronym, Centre de Données Astronomiques de Strasbourg. It's the Strasbourg Astronomical Data Center. It's hosted by the Observatory of Strasbourg and the University of Strasbourg. And it's been there for some time. Before the internet, before heavy use of computers, and even from that time, well before I became involved, it had a mandate which exists until today to collect useful data on astronomical objects in electronic form, to improve them, to not just put them there as they are, but to improve them by critical evaluation and combination, to distribute the results to the international community, and to really do research using the data. So the status of what we are now is a French data center supported as a contribution by France to the international astronomical community through the CNRS and through the Observatory of Strasbourg. But we also have international partners which are extremely important. So we're a French data center, but we serve the global astronomical community. Just in terms of size, we have 34 staff of an integrated team of scientists, astronomers, software engineers, and what we call documentalists, who are kind of professional data librarians. The CDS services are very heavily used. I'll show you some numbers in a moment. We're compliant with the standards of the IVOA. And we're evolving a lot. I mean, things are changing. Science is changing, so our data centers have to change, and the way we use data is changing. So in order to remain relevant in the era of big data and interconnected science, the CDS obviously has to change. We're a contributor to IVOA, and we really consider that part of our work as a data center. And there's a European coordination of that also through the European Virtual Observatory called EuroVO. Astronomers know the CDS. They know SIMBAD and Vizier, and I'll show some of those in a moment. So, and I think they trust us. They use our services. So, so we have a kind of reputation in astronomy. Outside of astronomy, it's a little bit more difficult to explain who we are. But now that we've gone down the path of getting certification through recognized international bodies that do that, for example, the data seal of approval connected to the ICSU World Data System, and now the Research Data Alliance, is a way for the funding agencies and for the wider community to see that what we do at CDS is certified in terms of being evaluated as providing stable services that have a level of quality associated with them. So those CDS services, I think perhaps some of you know them already, but let me explain a little bit. CDS services are for a Simbad, Vizier, Aladdin, a cross-match service, and the CDS portal. Simbad deals with astronomical objects outside the solar system. I think we'll hear a little bit more about planetary things a bit later on in this meeting. So Simbad is about the identification and, really importantly, the links to the bibliography. If you write a paper and you mention a new object or you mention an object that already exists, that gets captured by our processing of the whole literature, the whole astronomical literature. We put it in the Simbad data system, databases, and that allows the services to do what's called name resolving, so that you can do what was shown earlier. You know, you can type Markarian 421 into a box, and that text gets sent to us, and we send back what the coordinate of that is. So we do that for all of the literature, all of the objects that we possibly can. And that's a service which is heavily used. It gets about 500,000 queries a day. Alongside of that integrated database of astronomical objects, we have Vizier, which is a catalogue service. So here, if you publish a catalogue in your paper, whether it be 100 rows or whether it be 2 billion, it's very likely to end up in our Vizier catalogue service, which includes the published tables from surveys. For example, one of the most recent ones put in there is Gaia. We also have associated data, not just the tabulated, not just the tables, but also the spectra and time series that can be associated with publications. Aladdin is our visualization and integration tool, and you've seen some use of Aladdin Lite already during the presentations. So here's our integration portal. It includes images and access to catalogues at the CDS, but also through the VO, so we can consider it a virtual observatory portal. And what I'd like to bring out a little bit later in the talk is a very exciting new development that's come through Aladdin about using all-sky capabilities in astronomy. Aladdin is one of the tools alongside of Google Sky and Worldwide Telescope that have taken this approach of being able to do all-sky astrophysics in terms of visualization and access to data. One of the other services is the cross-match service, where we're able to do positional cross-matches of very large catalogues, including Gaia and Sloan, and there's been a lot of significant progress in this over the last years, because you can now cross-match those very big catalogues in a matter of minutes rather than hours or days. And on top of those services, we actually do try to be innovative in terms of our interfaces, and we have a single entry point to all of our services in the CDS portal. So we have data, but we are not a data provider like ESA or NASA or an observatory. We try to have the reference data of astronomy. So when we put in data into our system, we don't try and be a mirror of Gaia or a mirror of the Sloan Digital Sky Survey. Rather, we take a subset of the data that makes sense to put alongside of all of the other data. And we curate that into a system where we can describe it with describe the sort of heterogeneous data, but with homogeneous metadata. We are science-driven to maintain the relevance and quality, and we make all of that data completely openly available. We can only do that with the trust of the community, and that's very important through our connections to the astronomy journals and the authors behind that, to the archives of major observatories and agencies, and also to projects. So we want the CDS to be, good enough for those bodies to want to actually have their data interoperable there. The idea is not just to put the data there for preservation, but to make it useful. And the way to do that is through standardization of formats and conventions and protocols, so that these things can be used by all of the tools that are compatible with those. And the way to do that is by standardized metadata through the IVOA. And the key word being interoperability. Let me just give you one example for the data to do with photometry. I mean, it's a very common thing in astronomy. You have tables of the brightnesses of objects, and there can be very many tables, there can be very many objects. if we describe their photometry metadata in a consistent way, we can start to do very interesting things with it. For example, in Vizier, you will have multiple tables that have a column that has photometry information in it, whether it be magnitudes of stars or fluxes of radio sources. And so with the curated data where we've identified and the column with its photometric system, its filter curve and its transformations, we can extract that data and put that together, for example, in a plot like this. We've seen some of the things already done today, but that's driven by the standardized metadata behind it. Another example is where we have standardized metadata for time series, for spectra, for images, the so-called observational core data model of the IVOA, and that is behind our Vizier associated data service, whereby if you publish a paper and have a set of science-ready images or spectra associated with that paper, we can ingest them into that system. They're available through this interface, but also through VO protocol, so that any tool not developed by us, for example, TopCat or Splat or various other spectral and image tools, they can access those data. We are doing innovations with portals. We have our own new portal which we released last year. It's connected to our services, Simbad, Aladdin, and Vizier, but also NED, and allows us to integrate Aladdin Light into this thing. So it gives you a quick access to all of the data at CDS for a given object. Some of the most recent developments, as I mentioned before, have to do with dealing with all sky data and the adoption of an approach which we call hierarchical progressive surveys. It's a way of describing data on the sky that's applicable not just to images but to catalogues and spectra and anything that has an astronomical coordinate associated with it. It's called HIPS. There's a network of HIPS providers out there now, and there's a standardization of HIPS inside of the IVOA. I think the key to this is that it's a structuring development for the CDS, but it's also something that can scale with the very large data sets that are coming, where we're talking about LSST or SKA or Euclid, whereby data in a hierarchical representation can be made interoperable fairly easily, provided you have the storage to deliver the data. So that enables things like this. This is Aladdin, and we have an all-sky data set of the reprocessed IRAS data. We can put the whole archive of that data into the tool at one time, and the point being that when you zoom in, you access higher and higher resolution data. You can overlay on top of that the HST archive, which is done here, so that you access only the pixels that you really need in order to see what you want at a given time. And this concept has been put in different tools, and this is one which is built on the scientific basis of HEALPIX, so tessellation of the sky, and which is opening up all sorts of new ways of thinking about using data in astronomy. It's based on this hierarchical tessellation of the sky. This is a complex diagram, but just to show you that it's really rooted in using the whole sky and then going down many orders of magnitude based on what was originally developed by the cosmic microwave background community to deal with those microwave background satellites. People tell me not to use this table, but I like it because it shows that in this system, which is multi-resolution, you can deal with data that comes from WMAP with 7 arc-minute resolution on the sky, all the way down to an HST pixel with 25 milliarc seconds. So in a consistent system, you can deal with all those different sorts of data. There are tools like Aladdin Light that with a very small amount of code you can integrate into your own website, and we're very happy that those tools which have been made available openly have been integrated, for example, as was mentioned by Christoph, as the basis for the image display in tools like ESA Sky. But not only, also for various radio monitoring tools, the Spitzer Glimpse survey page, the NOAO data lab, and what's very exciting is that different communities are taking this up. For example, we have the LIGO SkyMap viewer, where they can use that system without developing their own to display the probability maps of where that gravitational wave may have come from as a function of position on the sky. So that brings me to sort of the use of these tools by not just the CDS, not just by our direct partners, but by the biggest infrastructures in astronomy. And we're involved in a project called Asterix, which is funded by the European Union Horizon 2020 program. Each one of these individual S-free instruments like the EELT or CTA or SKA or the KM3Net are, billion euro projects, and we have a 15 million euro project that helps to make the links between them to solve the common big data challenges. And I'd like to mention that that also includes a citizen science component of mass participation experiments, and that builds on the experience we've been developing in EuroVO over the years, whereby, we're talking a lot about the data here, but it's really enabling the people behind it to do something with it that's really going to bring out the science. We have had a strong program over the last 10 years of virtual observatory schools, and there are some pictures of them here from EuroVO schools, and also our Italian partner, who of course made a marathon effort of giving these schools all over Italy, as well as the connection to the education side, where some of these tools like Aladdin and others have been also put into an education mode so that they can be taken into the classroom, so that the same sorts of tools can be used by education as well as research to give hands-on experiences for young and yet less young people in the community. So in terms of the CDS experience, we make the CDS work because that's our job. The French research community pays us to do that, and we also contribute to the e-infrastructure of astronomy via the IVOA, and we have a set of organizations and structures in which to do that. And so I think in thinking about what the UN Office for Outer Space Affairs project or the Open Universe Initiative, what its role is, I would certainly like you to consider that in astronomy we already have a strong structure where a lot of these things are happening. At the local level, where there's national support and international partnerships. In Europe, we have things like the European Virtual Observatory. We have the International Virtual Observatory Alliance, which is a 15-year-old body which has, as Pepe described, gone through various stages and is now a mature infrastructure that can be built on. There is an overarching role for the IAU, and I would also mention that in terms of linking up astronomy and outreach, there are things like the IAU Office for Development, and they have used some of the tools built in these projects. We have communities such as ADAS, where we share the experience of making data interoperable and the real connections between our data centers. And even in a wider environment, there are organizations now which are really seeking the experience of astronomy sharing data. For example, the Research Data Alliance, which is a little bit like the IVOA, but going across all areas of data sharing for research. And so we are asked to give our input into those organizations, and some of us spend our time, for example, just last week in Barcelona, there were a number of us there sharing the experience of how astronomy came to its interoperable framework. There are, of course, challenges and as well as opportunities. Astronomy is now not just multi-wavelength, but multi-messenger. The way of publishing is changing. We're not just stuck with the typeset article these days, so we have data associated with publications. We're responding to the change in scale of astronomy, and that's a big challenge for data centers like the CDS, and I imagine also for the other agencies and observatories here today. There are new technologies to take up, and we have to take them up not too soon, not too late. We want to bring the code to the data because we're not just going to download data anymore. And I think our major emphasis is on adapting to make sure that the data centers that provide the data to the professional astronomy community and to wider communities adapt to meet the community challenges. And so I'll stop there. Thank you.
Thank you. Questions? Okay, thank you. So I leave the floor to my colleague. I'm sorry. So
Okay, so
will
now,
be
so now I'm
also
the
the
chair.
chair. Thank you.
That's what happens when you change the program.